Okay, we got the matrix equation AX equals B. We've determined the inverse matrix just by following rules, and these rules never change. So now I'm going to be able to write this out. Now the AX equals B matrix we've already written, or equation we've already written out here. I've rewritten it down here. This is where we start. So I got this arrow going from here to here. Now, there's a raucous advisory committee meeting going on across the hall. They're having fun, that's good. Okay, and they aren't bothering me, but we don't want it spilling over in the video, so I just kind of pulled the door a little bit. Okay, so we're ready to write down this step. Now, this step is very simple. We just put A inverse on the left of whatever we have here. Here and here. So what do we have here? Well, it's this. We put A inverse on the left of that. We still got this, so we've got A inverse on the left. Now, those parentheses aren't originally there. I added them, but since matrix multiplication is associative, I could put parentheses here or I could put them here. And I could work it out either way, it would come out the same. Okay, so anyhow, I put A inverse on the left of this mess. Okay, and then I put A inverse on the left of this. Right there's A inverse, right there's this. So now I've written out an equation that says A inverse AX, A inverse AX, X vector, X column vector, equals A inverse B. There's A inverse, there's my B column vector. Okay, what else is there to do? Well, not much. We just do this matrix multiplication. And we don't even actually have to do it, but it's a good idea to do it to make sure that you did the inverse correctly. Okay, well, if I multiply this matrix by this, I get the identity. Now, I'll show that, but it's kind of on another board, so I'll pull that out in a minute. But we get the identity matrix. And then that's times the XY matrix. I should have left that white. Let's try to make that kind of look white. Color coding, I don't know if it's even effective, but it helps you trace where things come from and when they change. Okay, so this times this is this. And I had people multiply that out, and you know, people were not as adept as they should have been at this point with the matrix multiplication. However, everybody got parts of it, and everybody sees enough of it that with just a little practice, they'll be fine with it, if they practice. Okay, so if you don't practice, don't expect to learn it. Okay, then we multiply this matrix by this and we get this. Now I've worked out the details of this matrix multiplication and this one, but it's just matrix multiplication. You just write it down, do it right, and you get the right stuff. Okay? So, well, if I multiply the identity matrix by the XY column, as we demonstrated over here with the aardvark and the anthill, I just get the XY vector. So the system becomes XY vector equals the 2, 3 column vector. And from that we conclude that X equals 2 and Y equals 3. Now that's the process. Once you get used to it, it's really a pretty simple and efficient process with a lot of important ramifications. Now we're not going to get into those ramifications in this course, but you might well have other courses later on, because students in this class are mathematically adept and could well profit, depending on their curriculum and what they want to do, from a little bit of linear algebra, which is basically what we're getting into with this. A lot more to linear algebra. It's a huge subject. With an incredible amount of depth. Okay, now maybe we want to see these matrix multiplications. I think they're right here. So I think that we can see them well enough. Okay, so one of the multiplications was the 3, -2, well, I'm sorry, was the you probably can't see it now, it's off to the left, but the matrix multiplication we did here to get the identity. Okay, and I've repeated it. Right there is the A inverse, and right there is our A matrix. So this is A inverse times A. So I might even write that down. A inverse times A is this. We do the multiplication. Okay? 5/23 times 3 is 15/23. 2/23 times 4 is, well, 2 times 4 is 8, 8/23. And we add those because when we do the row times the column, it's the first number times the first number plus the second number times the second number. Don't forget that plus. People were writing these down as two separate numbers without the plus in it and then getting confused about how big the matrix was and maybe even thinking that this was one number in the matrix and this was another number in the matrix. Very confusing. You have to write things down very carefully until you get used to it. Then you know exactly what you're doing. You know, you do a dozen of these and you've got it. Okay? Then we multiply this row by the second column. Now when we multiplied the first row by the first column, where did that go? That went in the first row of the matrix and the first column. Now we, I emphasized that in the preceding class and in those videos, so you look at those if you need to. The 5/23 times -2 gives us, well, 5 times -2 is -10. And it'll be -10/23. And 2/23 times 5, well, 2 times 5 is 10, so it's plus 10/23. Okay? And then we multiply the second row by the first column. -4 times 3 is -12, -12/23. 3 times 4 is 12, so we get plus 12/23. And then -4 times -2 is 8, so we get 8/23. And 3 times 5 is 15, so this gives us 15/23. We put the plus signs in the appropriate places, and we simplify. Well, 15 and 8 is 23. -10 and 10 is 0, so we have 0 over 23. And again, I'm not going to talk about anymore about the operations with fractions. I said that you need to be sure you know that. And I'm just going to take a look here and make sure everything I'm doing is on the screen. Okay, you need to make sure you know matrix operations, addition, subtraction, which are the harder operations, multiplication, division, which are the easy ones. Well, adding these, if I got -12/23 and 12/23, I got no 23rds, 0/23. And if I got 8 of these things and 15 of these things being 23rds, I've got 23 of them, 23 23rds. And 23 23rds is 1, and 0 23rds is 0, and right there's my identity. So that totally justifies what I did over here when I replaced this matrix multiplication that you can't quite see the whole thing of with the identity. So the identity goes here, which means, of course, then the identity times the xy is just the xy, so this is justified. And then, went ahead and multiplied the inverse matrix by the B column vector. Okay? There's the inverse matrix, there's our B column vector. That's this multiplication right here. Okay? Well, 5/23 times 0 is just 0, and 2/23 times 23, well, 2 times 23 is 46, that's 46 over 23. And people are doing pretty well with this, okay? There's a little bit of, some people a little bit shaky on it, but doesn't look too awful bad. Now, -4/23 times 0, of course, is 0. 3/23 times 23, well, 3 times 23 is 69. We get 69 over 23. Well, if you've got to use a calculator, go ahead, but don't reach for it until you know you need it, because it's really easy to see what 46 over 23 is. You kind of suspect this is about twice as big as this, and if you don't immediately see it, you just say, okay, what's double 23? Okay, well, double 20, it's 40, double 3, it's 6, 40 and 6 is 46, so this is 2. 46 divided by 23 is 2. And you can triple 23, okay? 3 20s is 60, 3 3s is 9, you get 69, 69 over 23, that divides out and gives you 3. That's where the 2, 3 comes from here. So our conclusion is x is 2, y is 3 should be a solution to our original system. Now, let's look at where we are, then we'll go to the next board and actually maybe write it out. I don't remember if we wrote it out. So, okay, plug in x equals 2, y equals 3 into the system. Does it work? People did, and it did. Okay? You know, x is 2, y is 3. 3 times 2 then is 6. Negative 2 times 3 is negative 6. 6 and negative 6 gives us 0. 4x is 4 times 2, that's 8. 5y would be 5 times 3, that's 15. 8 and 15 add up to 23. So we've solved our system. That should get your attention.